Hello, y'all, or all. This is the second time I doing this recording because guess what I did? I forgot to unmute myself. So it's all good. It's all good. Um, like I said in my earlier video that I had no sound, so I didn't unmute myself. This is the video that I promised you that I was going to record about one of the chapters. This is chapter 7, developing early numeracy. So let's get started. Maybe this won't be as long. I don't know. But here we go. Amistad does an excellent job at this topic, and I'm just gonna go ahead and get you started so that you'll know um, you have some type of background knowledge before you go to Amistad training in November. And this time they're gonna come to us, so I'm excited. So this is chapter 7, developing early number concepts and number sense. A very important chapter um, for developing number sense with your students. And so let's get started on this. Okay, here are your learning outcomes. Use a developmental approach to teach foundational number concepts. Demonstrate how to develop children's counting skill, including subatizing. And that's a very important word. I want you to know that word. 7.3 is develop children's ability to compare quantities and describe relationship between numbers, and support children's connection between mathematical ideas and the real world. So here we go. Developing appropriate early learning. Here are the 3 core ideas for teachers. In this book, it chapters start off like that. Oh, excuse me. Start off talking about developing appropriate or 3 core ideas for the particular chapter, 3 things that they feel important. And here there are: consider children's development and learning in general. Attend to children's individual children and their readiness. And let's say the individual children, although we teach a lot of kids at one time, we're gonna have to look at their individuality and their readiness to count. Okay. And then know what is culturally important to those children. Bridging that culture, yes, with our children, so you'll know how to relate mathematics and counting and those early number concepts, number concepts with those children. Okay. um so here is the development, how children develop appropriately with early learning. um They enhance children's natural interest in mathematics and assist them in using mathematics to make connections around the world. So they'll, we start talking about one finger, two this, 2 arms, 2 ears, one nose, but you got 2 nostrils. So you're kind of making it more real world to them. Build on children's experience and knowledge by using familiar context. Base mathematics curriculum and teaching practice on a solid understanding of both mathematics, math, and children development. So my early childhood people, you have a great job. So not only you have to look at the mathematics, you're going to have to also look at the child development theories. Use formal and informal experiences to strengthen children's problem solving and reasoning processes. Provide opportunities for children to explain their thinking about mathematical ideas and assess children's mathematical knowledge, skills, and strategies through a variety of formative assessment approaches. And this is all based on the position statement from MCTM, which I told you all about. MCTM as the one of the leading groups of organizations dealing with mathematics and learning. All right. So from there, you have the counting progression where children go through, and I'm looking at this progression in early counting. And these are the steps, learning steps. Compare quantities without assigning number values. They can discriminate between very large and very small amounts. They can identify a unit, They can also know, they know principles of counting, including subitizing, which is that word again. They can read numbers, write numbers, and recognize that written numbers are symbols for number quantity, which includes zero, knowing that zero is a real number. They construct set of objects given in numbers, including zero. They classify and reclassify groups of object sets according to one attribute. They approximate number magnitude, positioning numbers on a number line. So you'll ask you empty. We'll talk about that later. Compose and decompose numbers, and they work with tens as a unit. And move this out the way. They count to solve problems using concrete objects or modeling with role playing. So that's a lot of the parts of that's a progression of early childhood number sense or number counting. That's their learning progression. So you have these different core and counting with numbers. So you got the number core. Then from there you have the relation core. So let's look at the number core. The number core has several parts to it, and it's counting, um, quantity, counting, and cardinality. So look at counting and the ability to subitize quantity. I'm sorry, and the ability to subitize. When you look at an amount of objects, sometimes you just know the object without counting. You just say that's 5, that's 3, that's 4, that's 7. That's called supertizing. Okay, and there's two types of supertizing the book talks about. You got two types: perceptual supertizing and conceptual supertizing. Conceptual or perceptual supertizing is the instant mental recognition. Yeah, that is 4. Yeah, that is 5. Without counting them. Okay, then you have conceptual supertizing, and that's recognizing patterns to organize the information. You're recognizing patterns to organize the information. And the book, and that's on page 127, explains about the ability to supertize. And let's see if they go ahead and talk about those types of supertizing. Well, just know that we usually, when you just recognize that number, that's called perceptual supertizing. Then if you start looking and focusing on patterns, that is the conceptual supertizing. Encourage students to move beyond counting by ones as soon as possible and instead have them focus on patterns. So that's when you start doing that conceptual supertizing. Okay, let's go to the next one. Part of the number core is counting again. Counting, only the counting sequence of number words is a rote procedure. So remember the counting sequence: 1, 2, 3, 4, and 5. That's the only part that is rote. Okay, the rest requires conceptual understanding. Even if you're doing like skip counting, you gotta have some type of conceptual understanding about that. Like, why am I skip counting? Why, instead of me saying 2, 4, 6, 8, I don't say 2, 4, 5, 6, 8? Yeah, why? Because it's conceptual. Okay. Well, route counting, 1, 2, 3, 4, 5, 6, 7, all the way up to whatever, is a rote procedure. The meaning attached to a whole number counting is the key idea on which all subsequent numbers concepts are developed. Okay, so the meaning attached to it. So you see how they have this where 1, and then 1 it encapsulates 2, and then 3 and 4. Okay, that sequence is conceptual. Like you're adding 1 here. So you're developing patterns here. Okay. Now the book talks about the counting and the levels of thinking. Now, the only thing about this is that the book does not have the first one. The book doesn't have the first one. It doesn't have number word sayer. but they do have pre-counter. So I guess they call it pre-counter now. I mean, then and then they call it now number word sayer. Same thing. Here the child has no verbal counting ability. A child looks at 3 balls and will answer ball when asked how many. How many? Ball. The child does not associate a number word with counting. So they're just like, then you got your reciter. Your reciters are verbally count. They can verbally count using number words, but not always in the right order. Sometimes they say more numbers than they have objects. So they don't have that one-to-one correspondence, right? And they may skip some objects or repeat the same number. Do you have corresponders? They make a one-to-one correspondence with numbers and objects, stating one number per object. So they'll say, then if you ask them how many, at the end, they may have to recount it because they're not associating the last number, the cardinality aspect of it. Then you have a counter, and the counter is this child can accurately count objects in an organized display, and they mean like a straight line or array or something like that, and can answer how many at the end accurately by giving the last number counted. The last number counted. If you're counting something and they can say the last number counted, that's called cardinality. They may be able to write the matching numeral and may be able to say the number just after or before a number by counting on from one. So they're saying, yeah, yeah. Then you have producers. They count out objects to 5, then move to 10, and then go on. If asked to give 5 blocks, they can show you the number of blocks. So give me 5 blocks, and they can just give you 5 blocks. Give me 3 cookies, and they'll give you 3 cookies if they want to share. Then you have the counter and the producer. So that's both of those. A counter and a producer. So you got to get producer, and then you got a counter and a producer. Counts out objects and tell how many are in a group. The child can remember which objects are counted and which are not and respond to the random arrangement. They begin to separate tens and ones, like 23 is 20 and 3. So this is 20 and this is 3 more. Or this is 20 and this is 3. So that is a counter and a producer. Now, a person that counts backwards or counter backward, that's so funny, counter backwards. It counts backwards by removing objects one by one or just verbally as in a countdown. Like they can go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Or they can remove the object. Counters from any number. Counts on starting from numbers other than 1. They are also able to state immediately the number before and after a given number. Okay. And then skip counters. They skip count with understanding by a group of a given number. So they can skip count by 5s, 10s, 2s, and 3s, and so forth. And if they do 3s, boy, they something else. Um, but it lends itself to multiplicative thinking. Now, development of verbal counting skills and the learning trajectory, that's on page 128. Um, and then here it says research-based learning trajectories are called learning progressions, can help you design instruction that moves children to the desired goal by using information about the path on which these ideals typically develop. They have the counting trajectory, identifies the overarching goal of counting and how to help a child progress to more sophisticated levels of thinking through specific instruction. So it's just there for you to help your children go to the next level. Okay. Verbal counting has at least 2 separate skills. And then look at on here on page 128. They have 2 separate skills for producing counting words. And first, the order of counting. Okay, like 1, 2, 3, 4. And then second, a child must be able to connect this sequence in a one-to-one correspondence with the object and the set being counted. So they're doing 2 things, y'all. So early childhood folks, y'all have a arduous task. And those who are in elementary ed that are teaching kindergarten, through first to second, you got a big task to do. So it's imperative that the quality of time you spend, the 60 minutes you spend, has to be quality 60 minutes to build that. Now, here's another number core, and it's cardinality. So we got quantity and an ability to supersize, counting, and now we got cardinality, and all that is in the number core. So, cardinality is children learn how to count, matching counting words with objects. We talked about that earlier. That's part of the process. Before they understand that the last word stated in a count indicates the amount of the object set. So if I have some numbers here or some letters, I got some letters here, and I want to count this letter, and I have these letters here, not arrangement or not just count 1, 2, 3, 4. I have 4. I know this is 4 because this is the last set of letters or objects I have, and I said 4. So I have 4 letters. That's what cardinality is. The child does not count, but instead takes out counters. They said watch out for these. The child doesn't count, but instead take out counters and make a similar pattern. So let's say I have a little student, and I say, okay, count these. And they just go in and start taking out the same thing and trying to make a pattern. Okay, watch out for that. Okay, because we want our babies to say 1, 2, 3, 4, 5. The child recounts the dots on the card. So if you have, let's just say, these green letters, and I say count them 1, 2, 3, 4. How many? And I say how many how many letters you have, and they got to recount 1, 2, 3, 4. Then there's some things you need to do. Um, the child takes out counters in a one-to-one correspondence with the dots. The child remembers the number of dots and retrieves the correct number. So look at those. You're like, oh, yay. And then a child shows that there is the same number of counters as dots. So look at that progression. Check those out. Okay. Now, when we're thinking about zero, look at the age grade of the children who should know about zero. 3 and 4 year olds. They should have some concept of zero. Okay. Children can begin to use the word zero and the numeral zero to symbolize there are no objects in the set. So they start understanding zero at that age. Because early counting often involves touching an object, zero sometimes get left out. So um, when you do that, when you start the counting series, make sure that your students know that zero is a number. It's a real thing and it represents something. Okay. Zero is one of the most important digits. It's in the base 10, of course, because it represents the zero and the ones place for 10 and 20 and 30 and so forth. And it represents the zeros and tens and hundreds place. I mean, tens and ones place when you have 3-digit numbers. So make sure students know that zero is a number. It represents something. There are some games you can play here. I want you to look at those and read that to yourself. Then here's another thing that is important with counting. Learn how to write the numerals, and learn how to recognize them. Numeral writing is a skill outside of conceptual understanding. So numeral writing is not conceptual understanding. So let me tell y'all, when y'all start working on your EdTPA elementary, when they start saying the conceptual understanding, numeral writing is not part of it. So just take that out. Reading and writing numerals is similar to teaching them to read and write letters of the alphabet. Okay, because you're just writing symbols. Those symbols represent something. Engaging ways. Make numerals with clay. Get you some Play-Doh or some clay. Fashion it out. And then have the students make those numbers. Trace it with shaving cream. Let's see what else. Write them on an interactive whiteboard. Yeah, a lot of them students will have a in your schools you'll have an interactive whiteboard, Promethean board, or a view board, and they can actually write them out and have them trace them on the board. Looking at the numbers on your calculator or a keypad. My grandbaby likes to use my phone and he counts the numbers. He says the numbers. He knows what they are now. He can't write because he's just 2 years old. I'm kind of scared to give him something to write with because he might start writing on the wall. Time to clean the walls off. Okay. Anyway, common pre-K and kindergarten exercises have children match sets of objects with numerals. So if I had a set of objects, I have a numeral and I say number, let's say 7. And the reason why I put 7 is because it was right here first. And I had some pennies or I had some counters, and their job is to take out 7 pennies. That'll so that is 7. They recognize this is 7, and they can, pull out 7. And what if I'm recognizing this as 7, I would tell them, look at this number, pull that many objects out. Without actually telling what the number is. Because if I tell them what the number is, then they're not recognizing the number you told them. Right. So that's something. These tasks are called set to number and number to set. Children are given picture sets and asked to write or match the number with that tells how many. So I may give you a picture of, let's just say frogs or footballs, and I say, okay, how many are there? And they get to have to do it. Okay. Alternatively, they may be given a number and told to match a set with the many objects. You could do that with a number, and you can get some cards, and they could, or they can draw it out or whatever. Okay. Or get them some objects and pull those objects out. Important strategy also is counting on and counting back. Counting on is the ability to start counting from a given number other than 1. And it's considered it's a landmark thing. So if you have a some let's say kindergarten, they're supposed to rote count to 100. You could start off with any number and they should be able to count on. So if I said 25, not in the beginning of the school year, of course, but if I said 25, then they should go on to say 26, 27, 28, 29, 30. And if I say, okay, 32, and they should be able to say 33, 34, 35, so forth. Counting on from a particular number and counting back they're difficult skills, but it can be done with practice, with intentional practice, and some informal practice. Teachers can model by using a think aloud to share their thinking orally as they pull these multiple components together. So they can do like this is a think aloud. I see this number. This number is, I'm gonna go a low number, 23. I wonder if I can count from 23 backwards to 20. Let's see. 23, what comes before 3? Oh, 2. 22. What comes before 22 or 2? 1. 21. Okay, then 20. So that's how you do a think aloud. You're actually, I know you may sound silly, but you're actually thinking aloud, and the students are looking at you doing your thinking, your metacognition. First graders should be able to, look at what they said now. First graders should be able to start from any number less than 120, because that's where they have to go to 120, and count on from there. So like I say, 100, 101, 102, 103, 104, and so forth. And then here's a game that you can play. It's called Counting On with Counters. It's an easy game. You can get some pennies or some coins or some whatever you got that you can count, and you count out 10 to 12 of those. And you from left to right, just line them up. And then you cover up 4 counters. And you push them under your hand. They say your left hand, whatever. Or you could place them in a cup, but make sure the cup is not, like a clear cup, but a cup, cup. And then point to the hidden counters in the hand or cup and ask, how many are there? And hopefully they'll say 4. So let's count this, okay? And we could say 4, while you point it to your hand, You're saying 4, 5, 6, 7, 8, 9, 10, and so forth. Okay. Now, we're coming to the next core, and that's the relation core. So you have the number core and the relation core. The number core has 4 parts to it. It has quantity, it has counting, and it has, I forgot, counting, quantity, and cardinality. Oh, I forget cardinality. That's a yeah. Well, anyway, so here are some things that you could do. You're looking at more than and less than and equal to. The concepts of more, less, and same. They're basic. I mean, because children, they know. Because I remember my sister used to say, "She got more than me." You know how you get, "You got more than me." She got more. They know about more. Now less, they don't want less. So it's intuitive. So they know they want more, and they know they want nobody else to have more. So they know about more, but less is a harder concept. But they said this: the concept of less proved to be more difficult for children than that for more. A child unable to use more in this intuitive manner is at considerable educational risk. So make sure your students know about more, but they also need to know about less as well. But definitely more. If you test that out first. And there's this game right here that's in the book. It's in the chapter, less, same, more. When you produce, let's just say I have my dot images, and then I say same, less, or more, and they have to produce that. Okay. Number of developing number sense by building number relationship. Okay. Look at what they said here. Number sense is a good intuition about numbers and their relationships. About numbers and their relationships. It develops gradually, it's not overnight, as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithm. How can you get a traditional algorithm that teaches number sense? It's not one. So you have to build that. And when you have students that, still counting, I mean, you doing 5 and they say plus 1 and do 5 and plus 1. And, yeah, I mean, your fingers are natural manipulative. When you in 4th, 5th grade and they still doing it, they don't have number sense. So that's a problem. The ability to think about numbers flexibly and represent numbers with concrete material and symbol is an indication of number sense. Numbers and symbols. And they got to be flexible. Children continue to develop number sense competency as they use numbers and operations, build place value understanding, and devise flexible methods of counting and making estimates involving large numbers. So you can build those number sense using those relationships, using number relationships. And look at those relationships between numbers 1 through 10. Look at what they're saying here. Knowing the relationship of 7 as 7 is 1 more than 6, but it's also less than 9, 2 less than 9. You see that they talk about nesting and those numbers, one nested in the other. So 7 is kind of less nested into 6, but 9 is nested into 7. See that? Then we have 5 and 10 play a large role in the numeration system, and we're gonna figure out why. There's a reason why we use 10 frames and 5 frames. Conceptualize a number as being composed of 2 more parts. That's conceptual understanding. So if I know a number, let's just use 5 again or 7 again. I know 7 could be 2 and 5. 2 and 5. Okay, I know that because it has two parts, 2 and 5, and it makes 7. But there are other ways to make 7, and that's part of conceptual understanding. The principal tool children will use is counting. They use counting, especially with that part relationship. So if you're looking at that right there, and that that's 6, and they can count on is 7, 8, and 9. Okay. So I told you on the next slide we're gonna go back to the using these benchmark numbers 5 and 10. 5 and 10 are benchmark numbers. Okay. And that's why we use the tens frame and the fives frame, so that students can build that conceptual understanding of what is 5, their relationship with 5 or relationship with 10, and how those numbers relate to other numbers. It's highly important. The most common model for exploring those numbers are the fives frames and the tens frames. We use those with number talks, but you don't have to use with just number talks. You could just use it with different math strategies. Now look at this. This is part whole relationship. But look at the specific words with part whole relationship. We're composing and we're decomposing. What I mean by composing, just like you're composing a letter to somebody, or you're composing an arrangement to somebody, you're composing a poem. You can compose numbers by building the quantities, building the designated quantities. You have those two parts or more parts, just depending on your learners, and you composing those two, but from two parts. I have a game that I played. I don't have mentioned in this book. It's called Make 10, and it's an excellent game. I'll play it when we get back, and we'll find ways to make 10. And we compose those by, let's say, 2 plus 5, not 2 plus 5, Lord, 5 plus 5, 2 plus 8, um, and 9 plus 1, several ways. And then to challenge them, you can have more than 2 parts, maybe 3 parts. Okay. The next word is decompose. So you need to know those two words, compose and decompose. Decompose is you started with the full amount and now you're going to break them apart. And there are some things that you can do here. Okay. When children read and write the combinations, they focus on the relationship of the parts, right? And that start kind of leading into a lot of addition strategies. Okay. That is on page, what page is that? Give me a minute. Oh, page 142, when we start talking about composing and decomposing numbers. All right, then we have this thing. There's some more games that we could play, a variation of part whole relationship. You cover up, let's say you got 5 dots and or 6 dots, and you cover up two, and then you find out how many of dots on the outside. We know that's 4, so 4 and 2 that's under the tub equals 6. So in your book, they have the games and the directions to the games. I want you to kind of play a couple of those and jot it down in your notebook. Children are given the whole part amount and part of the whole, and then they use their already developed knowledge of part whole relationships to tell what the cover or hidden part is. Okay. And then there's some more strategies. Dot cards provide a wealth of activities, they say. And we've used those dot cards to develop number sense. Okay. This is called Find the Missing Dot Card. And information how to play it, well, it's on the slide right here, but it's also in your book. Then they got Difference War. Deal out the dot cards to 2 players and prepare a collection of about 40 counters. On each player turns over 1 card from the top of the stack. At the stack, the player with the greater number of dots win. Oh, that's war. Yeah. So that was just some awesome activities that build that thing. So math won't be just rote memory, here's the worksheet, so forth and so on. Label them, put them in your centers, and so you can build that mathematical relationship, and then have them accountable by maybe having them write about who won the game and how did they win the game. Let's go to the next one. Here's relationships for numbers 10 through 20. You have the learning progressions for understanding 10. You know, and everything. I mean, they've studied these things. Levels of thinking, initial concepts of 10. Understand 10 as 10 ones, and does not see the 10 as a unit. Just 10 and 10. We just have, a bunch of 10, This is 10 ones. When children at this level work on a task involving 10, they will count by ones. They won't say 10. They'll just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you got the intermediate, concept of 10, and understand 10 as a unit composed of 10 ones, but relies on material or representation to help complete tasks involving 10. They cannot yet carry out addition or subtraction with 10s and ones presented in a number sentence. So they're building to that. And then fossil concept of 10. Solve addition and subtraction situations involving tens and ones without using material or representation. So, they're a little older when they do that. Children at this level mentally think about two-digit numbers as groups of tens and ones. Okay. So when they learn the relationships between tens and 20, then we're going to pre-place value. And you can kind of see that because if you think about tens, we know that the first place value is ones, then we're going to tens, right? So when we start building that understanding, we start saying, okay, you count out whatever 15 is, and then you represent the 10 as something. Like this is a 10 block of something. I stack my 10 chips or my 10 counters, and then I have one. So let's start building that relationship. And then you're extending more than and less than relationships. The relationship of one more than you're extending that. All right, so I want you to look at this right here. These are two hundreds charts. And you look at the hundreds chart, you look at the differences between the two hundreds charts. Now, remember, kindergartners in the State Course of Study, you are expected to count to 100. And it doesn't matter where you start, they are expected to count to 100. So give them opportunity to see what that looks like. And they have two different models here of a 100 chart. And you tell me the difference between the two different models. And they said that model, the second one, 100 chart, it has some benefits to it. I'm not sure if it's in your book, so I'm gonna have to look that up. But yeah, a 100 chart replacing the number cards for a blank 100 chart that can help students reinforce those skills and those counting skills. Now, Amsci really don't like that. I mean, for younger kids, don't like the 100 chart, but I don't have a problem with it because you still got to go and count to 100. So, they to me, because you could look at patterns. Pull out the patterns in the 100 charts once the kids start getting a little older. Then we have number sense in their world. And young students need to examine relationships of numbers to real world quantities and measures to enhance their number sense. So what does then there's a strategy that they want you to cut out a large footprint and 18-inch long. I ask children to tell you how many of these will cover a particular rug. And we can do the same thing. How many of these will cover our floor? I don't know, that's something we could do. Something you could do in your dorm room is cut out a footprint of 18 inches and ask children well, you can't ask children, you can ask your roommate if you have one, Ask them to tell about how many will it take to measure the floor in your room or the rug in your room. Okay, more or less, then you fill in the blank, closer to, and so forth. This look familiar. I know it does. I know it does. It looks very familiar to you. And this is um generating data about their world. And we talked about this every time we do a daily data activity. Children can appreciate a teacher taking the time to get to know each other, and this is one of the get to know them, and this is one of the ways to get to know them. Younger kids can look at, okay, what's your favorite ice cream, what's your favorite snack, and older kids can too. However, you can think of older kids as, but this is we're talking about early numeracy, so um um you can pull those things out when it comes to number talks, like how many they when they start getting a little older, maybe second grade, you can say, what type of books do you like to read? What's your favorite genre? They know genre by then, trust me. um what did you do this weekend? Went to the movies, went to the park, or stayed home? They could do that. So just when you start thinking about relating math to their world, this is another way of doing it. And I'm not explaining it too much because we do that every week. Here are some common challenges. And in the book, they talk about what to do, what it looks like, and what to do as a teacher. I'm going to go over the first one. The child does not yet know the counting sequence. What does look like? The child might skip numbers or go out of order, saying 1, 2, 4, 25, 2. And you're like, what in the world? Yeah. Child may be able to count orally to a certain point, like they can go from 1 to 10, and then they start doing some strange things like 10 and 1 because they're trying to understand the world. So, this is how to help. Use a puppet that makes counting errors, right? I don't have what I don't know. I don't know what Jonah did with my bear, but I was gonna kind of do like that. But have them make counting errors, and then the student have the student correct it, or practice counting toward together out loud. Let's do it together. 1, 2, 3, 4. Right. Read counting books. There are several counting books. I have some. They are locked up. They're excuse me. They are locked up because we had to move. But there's some counting books out there. Um and I could find some for y'all. In fact, I may ask you to find some. And then prepare cards with numerals and have children place them in order on a number line. Something you can do. And match the written numeral with the written number word. So you want to work on that. Now, for your assignment, I want you to you can't use the one I just did. You know how I feel about it. So you can't do that. But what I want you to do is get one of these common challenges. There's several of them. Ooh, let me go back, go back, go back. They didn't show them all. They're in the book. So there's several of them. And I want you to make a video of you doing one of these counting challenges. They just gave you two here. The child counts without using a one-on-one correspondence. I'll let you have that one. Um, the child does not count on. The child is confused by perceptual cues such as spacing or size of counters, all that stuff. So they're on page 150 and 151. I want you to take that, make a video of yourself explaining, tell what it looks like, and how you can help the child. Now, I actually want you to actually act like you're helping the child so that I'll know that you have read the chapter. All right. There's some other words I want y'all to do. Let me see. Um, I want you to think about subitizing, knowing about the number core. Well, that's going to be a Blackboard question. And the relation core, that'll probably be the later Blackboard question. But for tonight's homework, I want you to talk about the challenges, common challenges. The next video I will make will be the next chapter, the operations behind counting, which is chapter 8, and I'm gonna make a video of that shortly. So I want you to be able to we stay on track, because man, next week I'll try to see if there's any misconceptions with the other ones that you need clarity. The red chapter is kind of straightforward, and then yeah, and then Amsty is going to go over that too, and then we're going to go back to developing um basic fluency, and then I'm going to go do place value, which is 9 and 10. um and next Monday. Please, Lord, don't let that have a meeting next Monday, because I'm gonna be like, for real, y'all. All right. I will see y'all next Monday. Make sure you do your work and read, look at the second video. Bye.